Hey guys, today we are looking at something called the measures of variation. So we've been dealing with statistics and mean, median, mode, and there's a few more, that we need to talk about here, right? That's what I'm getting at. Is one thing we can look at, other than just measures of center, which is what we have talked about with mean, median, mode, is we can look at something called variation, meaning how spread out is our data. So yes, it's really nice to know where the middle is, but another thing that's almost equally important is knowing how spread out is the data. How much variation is there in your numbers? And that's where we have this topic called the measures of variation. And it's another way to describe the distribution of our data set. So, if I have a data set where if I have a bunch of points, maybe I got a dot plot, if it looks something like this, the average is probably going to be here. But if I have a data set that looks something like this, that average is going to be in really about the same spot. But there's a huge difference between my first set of data and my second set of data. So even though they'd have the same mean, one is a lot more spread out than the other. And so one of the measures of variation that we use is something called the range. And what we do with that then is we try and find the difference between the greatest and the least value. So, all right, my biggest value on this set is here. My smallest value is here. If I subtract those, that gives me my range. Okay. Similarly here, biggest value, smallest value. If I subtract those numbers, I get my range. And so that's another way that we can describe the difference between data sets. All right, so this one here is asking us to find the range. So, we could list all of ours in number, but again, what we need to do is we need to know what is our biggest data set here if we're going to find our range. So my biggest number is 18.5. My smallest number in my list looks like it's 5. So if I subtract those, I end up with 13.5, and in this case, that would be the range of my data set. Another thing we want to talk about with data is, all right, range is important, right? It measures from start to finish, but what if I want to look at the things in the middle, right? Like, more than just the end and the beginning. What if I want to, talk about some more measures in there? And that's where we can use kind of this idea of quartiles. And of course, the root of the word quartile is quart, meaning 4. Okay? So your quartile is going to divide your data into 4 equal parts. All right. Now, we already kind of do something like that, and that's when we find our median. And the median, of course, splits our data in half, right? The smallest half, the biggest half. So this really is the same as our second quartile. Let's look at an example, okay? But before we get to that, another thing we can do then is look at the range between these, and this is something called the interquartile range, all right? So if I find my first quartile, my second quartile, which is also my median, and then my third quartile, the distance from the first to the third is what we refer to as our IQR, or our interquartile range. All right, now we got the example I was talking about. So here we got a dot plot, so a way for us to get data that's showing the top speeds of 12 different sports cars. So it's asking us to find and interpret the interquartile range of this data. All right, so what do we need to do? First thing we got to do is order these speeds from slowest to biggest. So I have a 220, I have a 230, actually two 230s, two 240s, 245, 250, 250, 250, 260, 260, and then 270. I just abbreviated those last ones because I ran out of room. All right, so if I want to find my quartiles, I need to divide my data up. And when you're finding your quartiles, it's always easiest to find that median first, right? And we know that we could go in, like one number at a time, okay? And if I do that, right, I went in 1, 2, 3, 4, 5 here, 1, 2, 3, 4, 5 here, and I got 2 left, right? So between 250 and 245. So if we need to find a median or a quartile, right, that's between two numbers, we take the average of these two. So we're looking for what's right in between them. So if I do 245 plus 250 divided by 2, I end up with 247.5. Okay, so my second quartile, or my median, would be 247.5. Okay, so now it's asking us to find all of our quartiles, and we're actually going to have like 3 quartiles is what we're looking at. Okay, so what do I do next? Well, let me look at my first half of my data. All right, so your first quartile is going to be halfway between your start and your middle number. So if I work my way through, basically I'm just trying to find the median of these numbers, right? That would be halfway between 230 and 240, which would be 235. Okay, and then on the other side of things, right, looking at the quartile for our top ones, right, again, I can work my way through, so I get halfway between 250 and 260, which would be 255. All right, so I've listed all of my quartiles, okay, and now if it's asking me, right, to find and interpret the interquartile range of my data, again, our definition was we're going to take our third quartile and subtract our first quartile. So 255 minus 235 would be 20, okay? So what does that mean? Well, that means that from the first quarter of my data up to the third quarter of my data, so really what that is, guys, middle, first quarter, second quarter, or third quarter, I should say, your distance between your first and your third quartile is the middle half of your data. So this says that the middle half of my data has a width of 20, right? So in this case, all of these sports cars have a maximum speed, or the middle half, I should say, of my sports cars have a maximum speed of 20 miles an hour, or a difference in 20 miles an hour of their maximum speeds. All right, let's look at another one here. Okay, so finding your quartiles, asking you to find the quartiles in the IQR, just like we did in the last one. Go ahead and try this one on your own. So pause your video, see if you can figure it out. Okay, guys, so if we look at this, we can find our median first. So to find your median first, right, we work our way across, okay, and we find a middle number of 382. So that's my median, or my second quartile. Now to find my first quartile, all right, I'm looking at the bottom half of my data, so I've already used 382. That was my median, so I don't include it here. So I got 4 data points, find the middle, halfway between 356 and 364 is 360. That's my Q1. Same process over here for Q3, all right, halfway between 396 and 400 is 398. So now I know my Q3, my Q1. If I subtract those, that gives me my interquartile range, which means 38, right, is how much it's spread out from the beginning of my middle half to the end of my middle half. All right, so last piece for today, looking for outliers. And in the past, you know, we've defined outliers, we've used outliers, we've talked about them, but we really haven't had a formula before to determine, all right, is that an exact outlier, or is it just kind of a big number? And that's what we're looking at today. Okay, so this is where this IQR comes in common, or comes in helpful, right? We know our IQR is our third quartile minus the first. Okay, now if I want to find an outlier, so a small number, okay, to find out where the outliers would be, it's going to be Q1, so your first quartile, minus 1.5 times your IQR. Anything less than that is an outlier. Similarly, on the other side, I use that IQR. I take 1.5 times my IQR, and I add that to my third quartile. If we do that, anything bigger than that is going to be considered an outlier. Let's look at an example. So again, what we want to do here is, list our data from smallest to biggest. So if I start here, it looks like 23 is my smallest number. My next number then would be 32. Then I have 37. And I got 42. I have 54. 55. 65. 77. 80. Oop, I forgot one, didn't I? I forgot 69. So I got 69. Okay. Let's see, what did I erase here? Yep, 69. Okay. Then I got sorry guys, 69, 77, 80, 94, and 145. All right, so I should have 12 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, so we got all of our numbers in order. We got that done, okay? Excuse me. Now we're going to find where the middle of our data is. So we only have 12 numbers. So if I count over 1, 2, 3, 4, 5, 6, halfway between those is going to be my center. So that would be my Q2, right? Which would be at 60. Okay? Now, I'm going to look at the first half, the low half of my data, right, and figure out what I got going on here. So I got 6 numbers here again. Halfway between those would be right in the middle. Halfway between 37 and 42 would be 39.5. Okay? So there's my first data point there for my Q1. Okay? On the other end here, I'm going to go over 3, right? So halfway between 77 and 80 would get us that 78.5. That's my Q3. All right, now what I need to do is I need to find my IQR, which again is I'm going to take Q3 minus Q1. So if I do 78.5 minus 39.5, I end up with an IQR of 39. All right, so that means my data is spread out. Okay, again, how we find our outlier, right, is I'm going to do Q1 minus 1.5 times my IQR. All right, so that means any number less than what I get for this formula is considered an outlier. All right, so quarter 1 was 39.5. Okay, and then if I subtract 1.5 times 39, well, we're going to get a number less than 0 here, right? And in fact, if we go ahead and do that, 39.5 minus 1.5 times 39, I get negative 19. So anything less than negative 19 would be considered an outlier. Obviously, I don't have that here. Okay, looking at the flip side of that then, right? How do we find our big outlier? And that's where we said we take Q3 plus 1.5 times the IQR. So here my third quartile is 78.5. And if I do 1.5 times my IQR, all right, if I plug this back in, okay, so 78.5 plus 1.5 times 39, I get 137. So any data point over 137 would be an outlier. Do I have a number over 137? Yes, I do. 145 would be considered my outlier. Okay, last example here. Why don't you give this one a shot on your own and see if you can find the range and the IQR, and then determine, are there outliers? Okay, guys, so again, I ordered my data here from smallest to biggest. To find my range, I take my biggest number, 193, minus my smallest, which is 21, so I get a range of 172. Divvying up my data to find my quartiles, 93 is right in the middle. 74 is the first quartile, okay, and here I got 116. Okay, so if I use these numbers for my IQR, I come up with an IQR of, I'm sorry, I made a mistake here, guys. Okay, guys, I apologize for that. I just grabbed the wrong number from my list over here. So, to find the IQR, right, we take our Q3 minus our Q1, which is 73, or 74. 116 minus 74 gives us 42. Okay? To determine if we're going to have any outliers, then we'll use our equation. So, to find if there are any low outliers, I would take my first quartile, 74, minus 1.5 times my IQR. If I do that, I get 11. So that means any numbers less than 11 would be considered an outlier. I don't have any numbers less than 11, so no low outliers. On the other side, I take my third quartile, 116, and add that to 1.5 times 42, which is the IQR. I get 179. If I have any numbers over 179, that's an outlier. So 193 is an outlier.